chapter, that is the linear equation in one variable. Okay, and I sent you an assignment also. You had
Yes,
to
sir.
solve exercise number 1. Did you solve that exercise?
No, sir, I am still solving it. The few
Still
more
solving
questions.
it.
Yes, sir, just few more questions.
Okay, so far any problems you face while solving the questions?
No, sir.
Okay, very good. So in our previous class, we begin with the new chapter. Let's quickly revise what we had to discuss in this chapter. First, meaning of an equation. Okay, what is the concept of this chapter? What do we mean by variables? Okay, what are constants and what are terms? And one more important thing, what are coefficient? Okay, you might not have heard of the word before. Let's quickly revise them. So you see, we have got variables and we have got constants. Variables, you know, they are basically representation of numbers using alphabetical words, alphabetical letters. It could be A, X, Y, Z, anything. Or constants are basically, they are whole numbers. Okay, so it's 1, 2, 3, 4, including 0, 4, 5, etc. And they are called what? They are called terms, right? Okay, and using these terms, what do we make? Using these terms, we make algebraic expressions. Like if I provide you with a variable x and I provide you with a constant 2, we can add them or subtract them or multiply them or either divide them and get an expression. It could be x plus 2, it could be 2x, it could be x upon 2, it could be x minus 2, right, Ahmed? And these are all called algebraic expressions. Okay,
Yes, sir.
now using these algebraic expressions, we derive equations, we form equations, right?
Yes, sir. Yes.
Okay, so it could be like this: x plus 2 equals to 3.
Yes,
Okay,
sir.
it is an example of an equation, right, where we are taking help of algebraic expressions to
Yes.
form an equation. Here you have equality sign. Okay, so here we have got an equation. Okay, where on one side of the equality sign we have written a linear expression here. This is a linear expression, and on the other side we have got a number, a constant value. So here this is called an equation. Okay, where there's a hidden value of x here, and if we put that hidden value of x over here, both the sides on the equality sign will become equal. If we put 1 in place of x, then it will be 1 plus 2, that is 3, 3 equals to 3. Okay, so that is the equation. Okay, now see this figure here, observe here. Okay, here we have got variable, that is x is the variable here. We have got a constant value, that is 2, 2 is a constant here. 4 is also a constant here. But since 4 is being written here together with variable, it is in multiplication with variable here. So it is called coefficient. Okay, Ahmed. Remember this term coefficient. Okay. For the present exercises, you might not need to know about coefficient, but for higher exercises, you must know about this. The constant attached with the variable is called coefficient. In simple terms, what does it mean? Simple terms, the constant attached. Attached means in multiplication with the variable is called what? Coefficient. Okay, that is called a coefficient. Okay, So this thing was actually left in the previous class, so I thought let's discuss this also. Okay. Okay. Now, if we talk about equation, what would be the definition of an equation?
Mm, uh, any numerical expression with a
Yeah,
equals to sign.
exactly. It's a numerical expression in which it's a numerical expression in which constants and variables are used, okay, with the sign of equality. Okay. So some typical example of equation will look like this. 2x plus 3 equals to 5. That is an example of an equation where you have gotten equality sign. Okay, that is an example of equation. Okay, so what do we say? It is a numerical expression with the equality sign and consists of variables and constants. Right, variables and
Yes, sir.
constants. Now, if you see the headline of the chapter, it's actually it says linear equation. So what does this linear equation here means actually? Let's say we have got few equations here. Let's take few examples of equations here. Let's say it's yeah. Let's say we have got 2x plus 1 equals to 8, x square plus 5 is equal to 9. Okay, x cube plus 3 equals to 12. Okay, then
Yes, sir.
x raised to the power 4 plus 5 is equal to 25. And we have got x plus 2 equals to 10 here. Now, there are 5 algebraic expressions here. These are all algebraic expressions. These all consist algebraic expressions. Okay, remember, it's algebraic expressions which gives you equations here, different equations. All of these are different equations, but not all of them are linear equation. All of these are equations, but not all of them are linear equation.
Okay, sir.
See the first one here. See example number 1 here. That is x plus 2 equals to 2 equals to 10. What is the power of the variable given here? What is the
Uh,
power of x here? You already know. You must be aware about the term power of the variable. What does
yes,
the power of the variable mean? Like x raised to the power 2, that means x multiplied x. So x multiplied x can be written as x square. Okay, x raised to the power 2, or we call it also x square. And if you multiply x 3 times, in short, that can be written as x cube. So the constant value over the head of this variable, it is called what? Power. This 2 and 3 here is called power. So what is the power of x here? It is
uh,
actually 1. Okay, Ahmed.
yes, sir.
So if x is not being multiplied, that is simply x to the power 1. X to the power 1 simply means x. Okay. So those equations in which the power of the variable is 1, that is simply called as what? Linear equation. Note this thing that those equations, yeah, let me erase this one. Linear equation. Okay. So what did I say? That those equations in which the power of the variable is how much? Yes, Ahmed,
Power of 1.
is 1 are called what? Linear equations. Okay. Now identify from the given example another linear equation in the example is in the above given examples there is one more linear equation. Can you spot it?
Um, the
See example number 3.
2x.
2. Did you say 2?
Yes, 2.
Yeah. Ahmed, come close to your mic. Your voice is not very much audible. Okay. Come close to mic. So 2 is the example of a linear equation and 1 is also an example of linear equation. While if you see example number 3 here, what is the power of the variable x here?
2.
2. But as per the definition, the power has to be 1 here. Okay. So is to option number 3, is it a linear equation?
No.
No, it is not a linear equation. What about option number 4?
No. It's
That is
3.
also not a linear equation. Okay, option number 5.
No.
That is also not an example of a linear equation. So the definition of linear equation basically means those equations in which the power of the variable is 1. That is simply called as linear equation. Okay. Okay. So in the previous class,
Yes, sir.
I gave you few questions in which you had linear expression on one side and on the other side you had constant value like this. Okay. On one side you are provided with linear equation, on the other side you have got constant values, and we solved those questions. So entire first exercise on your NCERT is based on this thing. Okay, if you see the exercise, yeah, exercise 2.1. On one side you are provided with linear expression and on the other side of the equality sign you are provided with constant, and you had to find the value of x. One more thing to discuss here is that what does solution of equation mean? Okay, let's discuss one more concept here. Solution of equation. What does it mean? Ahmed, any idea?
Solution of
Solution of equation. Solution of equation. Okay. Solution of equation means nothing, but it actually means the hidden value of the variable given in the equation. Like if I say x plus 10 equals to 20, and if you solve it and you find the value of x to be 10 here, so the solution of the equation is x equals to 10 here. Okay. If you are provided with another question, x plus 12 equals to 28. In this case, what is the solution of the equation?
uh,
Ahmed, mute yourself and then unmute yourself. There's some glitch in your mic. There's some issue with your mic.
okay, x. Sir, we will transpose the number.
We will transpose the number to the right
10
side.
minus 10.
28 minus 12. The given value is 12.
Yes, sir. 12 minus 28.
28 minus 12. So that will be
That will
6.
be 16, yes.
Yeah. So the equation of the solution of this equation is 16 here. Okay.
Yes.
So it is actually the hidden value of the variable that is called the solution of equation. Okay.
Yes,
Okay.
sir.
So your entire exercise was based on this thing. Okay. So solve few questions. Solve question number 8 here. Solve question number 8 of the exercise. Has this exercise is this exercise completed in your class?
Yes, sir.
Okay, okay. So it must be easy for you to solve this question then.
Yes,
Question
sir.
number 8, solve this one.
Hmm. Divide. Okay.
Miss Ahmed, got the answer?
No, sir, I'm solving it.
Okay, okay, take your time.
Sir, the solution is 2.4.
2.4.
Yes, sir.
Okay, very good. 2.4. Okay. Solve question number 11 then.
17 plus 6 equals to 9. Okay. 29. Sir, minus 4.3.
Minus 4 upon 3. Okay, that is correct. Okay. Question number 12. That one is also simple. Okay. Solve this one also.
Okay, sir.
Yes, Aman, got the value?
No, sir.
Okay. Transport the fractional value on one side. Okay. Bring
Yes,
the
sir.
x upon 3 on the side of 7 upon 15. Then solve this question.
Oh, okay, sir.
Yes, Ahmed.
8 upon 5, sir. Minus 8 upon 5.
Minus 8 upon 5. Very good. Okay. Answer is correct, but you have taken too much time to solve this question. You need to practice these type of questions more and more, Ahmed. Okay. Okay.
Yes, sir.
Okay. So I'm giving you few questions based on the same pattern. Okay. Similar questions. Solve them. Y upon 3 plus 11 upon 15. Okay. Equals to 9. Okay. Solve these two questions.
Okay, sir.
First, you need to bring the constant
Oh,
values on the one side. Okay.
okay.
It has to be like this. 5 upon 3 equals 9 minus 11 upon 5. 11 upon 15. Okay. Then take the LCM and then do further.
Okay, sir. Y equals to 124 upon 5.
Y equals to
Oh, 124
124 upon 5.
up. Yes.
Okay. So let's see that. It's 135 minus 1 minus 11. Okay. So y upon 3 gives you 124 upon 15. Okay, very good. Okay, it's 124 upon 5. Okay, very good. What about second question?
I'm doing that one right now.
Yeah.
Um, X equals to 1464 upon 5.
X equals 1464 upon
5.
5. Okay, that one is also correct. Very good, Ahmed. Okay, now further you have got questions. What problem questions? Okay,
Yes, sir.
now see questions like this. See example number 5 here. Okay, which says that what should be added to twice the rational number minus 7 upon 3 to get 3 upon 7? Okay, so how do we solve those questions? Simply we will take a variable here. Okay, the number which has to be added, what should be added? So the number which has to be added, let's take that to be x. Okay, now then follow the question. What does the question says? To twice the rational number minus 7 upon 3 to get 3 upon 7. Okay, so question basically asks you to find that value when added to twice of minus 7 upon 3 gives you 3 upon 7. Okay, shall I explain or will you be able to solve this?
Can you explain it, sir?
Okay, sure. So these were number, right? Minus 7 upon 3 and 3 upon 7. Okay, so let me spread the screen so that you can see the question. Yeah. So the question says, what should be added to twice the rational number minus 7 upon 3? Minus 7 upon 3. So first we find its twice value. So the twice of minus 7 upon 3 is simply going to be 2 multiplied minus 7 upon 3. Okay, that is going to give you minus 14 upon 3. Right. Now, read the question again. What should be added to twice the rational number minus 7 upon 3 to get 3 upon 7? So let's assume the number to be added as x. So we have taken a variable here. Now, according to our question, x plus twice of minus 7 upon 3 should be equal to 3 upon 7. So twice of minus 7 upon 3 is what? Minus 14 upon 3 here. Okay, see this here, twice of minus 7 upon 3, that give you minus 14 upon 3. Okay, now so when you add x to this twice of minus 7 upon 3, that should be giving you 3 upon 7. So we have got our equation here, that is the required equation. Now simply you need to find the value of x. How we derive this equation, is it clear?
Yes, sir.
If not, I will explain again.
Okay, sir.
Okay, look, questions, read the question carefully. What does the question says you here? That what should be added to twice the rational number minus 7 upon 3? Okay, what should be added? Let's say I am adding x here. So the value to be added, I am saying that it should be x to what? Twice of rational number minus 7 upon 3. So twice of rational number minus 7 upon 3 means 2 multiplied minus 7 upon 3 here. So if I add x to twice of minus 7 upon 3, it should give me 3 upon 7. That's what the question is saying, right?
Yes, sir.
That's what we did. So minus 14 upon 3 here, it was initially, it is what? It is same as this now.
Yes, sir.
It is same as this. Okay, now we can very easily solve this equation. So plus minus here will become minus, this plus minus will become minus here when multiplied. So it will be x minus 14 upon 3 equals to 3 upon 7. Now it has become very easy. We can solve them. So transposing minus 14 upon 3 on the right side, it will be in addition with 3 upon 7. That is 14 upon 3. Take the LCM of 7 and 3.
7 and 3 is LCM. Okay, sir. Three threes are three. 21.
21. Okay. So numerator here is going to be 9 and here it is going to be 98, right?
Yes, sir.
So the value of x becomes what? 107 or 17?
11.
107, right? Upon 21.
Okay.
Okay, so this is the required value of x. You can actually verify that also by putting this value on the given equation. Okay, so by adding 107 upon 21, 2 minus 14 upon 3, you should be getting 3 upon 7. Okay, we can actually verify that also. Let's do that also. Okay, so LCM of 21 and 3 is going to be 21, right? So it's 107
Yes, sir.
plus minus sign will become minus here. Then it's again 7 multiplied 14, that is 98. 3 upon 7. So 107 minus 98 should give you how much? 9.
Yes.
Okay. Isn't the two values same here? Simplify it. 3 upon 7. So you have got 3 upon 7 equals to 3 upon 7. So we actually verified our answer also. Okay. So that's how you need to solve questions where you will have to simply assume the unknown variable as x or y or anything and then just follow what the question is saying. Similarly, have a look at question number example number 6 here. That's also a very good question here. What does the question says? Read this question.
Okay. Question number, sir.
Example number 6.
Oh, the perimeter of a rectangle is 13 centimeter and its width is 3 upon 4 centimeter. Find in length.
Find its length. You have need to find its length. Perimeter is given here. Okay. Perimeter here is given. How much it is? 13
Thir-
centimeter.
yes,
Okay. So, and what else is given here? Width is
2,
given, no?
yes, with 2 3
Width.
upon 4.
Okay, that can also be written as 11 upon 4 centimeter. No issue in that.
Yes,
Okay. Into proper fraction, it can be written like that. So we need to find its length. Okay. So you need to assume the length to be any variable. Let's assume it to be x centimeter. Okay, we have assumed length to be x centimeter. Now we know already that the formula to find perimeter of a rectangle is 2 multiplied length plus breadth. Okay, length plus breadth. Breadth or width both are same. Okay,
yes,
whether
sir.
you say breadth or width both are same thing. So as per the question, 2 multiplied L plus B, what is the value given here? What is the perimeter given in the question? It is 13 centimeter, isn't it?
Yes, sir.
Okay. See what the question here basically says you. Yeah. Perimeter you are provided with how much? It is 13 centimeter. Width is given how much? 11 upon how much it was? 11 upon 4 centimeter, right, Ahmed?
Yes, sir.
You need to find its length. Okay. So what first we will let's assume the length to be x centimeter. Let's assume the length, okay, to be x centimeter. Now, according to the question, perimeter given is 13 centimeter. What is the formula to find the perimeter? 2 multiplied length plus width. Okay.
Yes, sir.
So which according to question is equal to how much? How much?
Um,
This is basically the formula to find perimeter. And according to question, it has been given 13 centimeter, isn't it? I was just written it here, Ahmed.
yes,
Okay.
sir. I'm
Okay. So it has been given as 13 centimeter. Now, in this formula, just put the length and width. What is the value of length here? Which we have assumed as x centimeter. Okay, we have assumed length to be x centimeter. So let write length as x here. What is the value of width given in the question?
11 upon 4.
11 upon 4 centimeter here. So write the given value 11 upon 4 here. Okay. Now, as per the question, this value is equal to 13 centimeter. The perimeter is 13 centimeter. Okay. Now here we have got our equation. Okay, this is the required equation. And when you will solve this, you will find the perimeter. Basically, we have equated the formula to find the perimeter with the perimeter given in the equation. So in
Yes,
this formula, we simply put it the assumed value of length, and we have also written the given value of width here. So when you will solve this, you will be able to find the value of x here. So 2 is in multiplication with the values inside the bracket. So it will be what? 2 multiplied x. How did we multiply this? Remember the distributive property?
yes, sir.
Okay. So mention what it is going to be. If you further simplify it, how will you
Mm,
write this in the next step?
uh, 2 upon 13.
No, it is similar to this value. Okay, it can be written like this: a multiplied b plus a multiplied c. So first you need to multiply 2 with x. So it will be 2x like this. Okay. Then multiply 2 with 11 upon 4. So it is going to be 2 multiplied 11 upon 4. Okay. So in the next step, it is going to be 2x. Now, since they are in multiplication, you can cancel 4 by 2. So it is going to be 11 upon 2. That is equal to 13. Got this or any confusion in this, Ahmed?
No confusion, sir. I got it.
Okay, okay. Look, we got till this step. Is there any confusion till this step?
No, sir. Absolutely not.
Okay. After this step, you are having confusion. Look, remember how in the distributive property we wrote numbers like this? If you're provided with a multiplied b plus c, that can actually be written like a multiplied b plus a multiplied c. Remember,
Yes, sir.
in rational number, we discussed about distributive property of multiplication over addition, in which we wrote numbers like this. Okay, it was basically this thing. Okay, a multiplied b plus a multiplied c. So here you are this consider them as a, b, and c. Okay. So first multiply a with b, that we have written as 2x, a multiplied with this a multiplied with x, that we have written x, 2x here. Okay. Now then a multiplied with c. So this a has been multiplied with c here. Okay. This 2 and this 11 upon 4, which we multiplied here. Yes, Ahmed.
Yes, sir.
Okay. Let me give you an example. Then it will become clear to you. Let's say 2 multiplied 5 plus 12. Okay. Write this according to this formula. How will you write this?
Um, in 2 into 5, 2 into
2
12.
into 5. There has to be addition sign it between them now. Then 2
Yes,
into
sir.
12. Same thing we did here. 2 into x we wrote over here. Then what? 2 into 11 upon 4 we wrote over here. And in between you have got addition sign. Okay. It is the same
Yes,
thing. There shouldn't be any confusion in this. Yeah, Ahmed.
yes, yes, sir.
Or if there's any, feel free to ask. I will explain again. Okay.
Okay, sir.
Yeah. So what we did, we simply simplified it further. Then it will be 2x plus 11 upon 2 equals to 13. Now you can solve the equation. Okay. So take your time and find the value of x here. What is the value of x here? Okay. And by the way, what actually we are
Okay,
trying
sir.
to find in this question? We are trying to find the length of the
We are trying to
rectangle here.
find okay.
Okay, I'm gonna solve the question.
Sir, x equals to 40 up. Sir,
Yes, Ahmed.
equals to 41 upon 8.
41 upon 8. Okay, let's check that.
Yes, sir.
Okay. 2x plus 11 upon 2 equals to 13. Now you will transpose
Yes, sir.
11 upon 2 to the right side. That will become 13 minus 11 upon 2. Okay. Match my steps with
Yes,
yours. Okay. So it will be, we will take LCM. So it is going to be 26 minus 11. Okay. Then 2x equals to 15 upon 2. Now again, we will transpose 2 to the right side, then it will be in multiple division with the value. So 15 upon 2 divided 2. X equals 15 upon 2 multiplied 1 upon 2. That gives you 15 upon 4. Okay, Ahmed. So your answer has to be 15 upon 4. This is the required answer here. Okay.
Yes, sir.
In case if you have confusion, then you can actually check whether your answer is correct or not by putting this value in the equation here. In this equation, we can do that as well. So let's verify our value. Okay. So 2x plus 11 upon 2, that is equal to 13. So our answer was 15 upon 4. So it will be 2 multiplied 15 upon 4 plus 11 upon 2 equals to 13. So that gives me 15 upon 2 plus 11 upon 2, right, Ahmed? Equals to
Yes.
13. So here the LCM is 2 and the above value will be added. That will be 26 equals to 13. Now, isn't both the sides same here? It will be cancelled. 13 equals to 13. So you can actually verify your answer like this also. Okay. Okay. Now you have got few other examples also. See the next example. That one is also a very good example. Okay. Read the question. What does the question says here? Example number 7.
The the present age of Sahil's mother is 3 times the present age of Sahil. After 5 years, the age will add it to 66 years. Find the present ages.
Okay. Now in the question, the age of Sahil's mother is said to be 3 times the present age of Sahil. So who is Sahil here? Sahil here is the son of is the son of the mother given in the question. Okay. So if we say the age of Sahil is 10, then the age of Sahil's mother is 30. That's what the question is saying. If the age of Sahil, let's say, is 20, then the age of his mother must be thrice of his age. That means it will be what? 60, 3 times.
Yes, sir.
Okay. But we are not provided with the exact age of Sahil and his mother. So we will assume the age of Sahil to be X. Okay. Then his mother's age will become 3x. That's what we have done here. The present age of Sahil has been taken as X. Okay, Ahmed. Then
Yes, sir.
his mother's age will become 3x as per the question. Now, after 5 years, their ages will add to 66 years. Okay.
Yes, sir.
Read the second line. It is very important here and it might be confusing a little bit. What does it say? That after 5 years, their ages will add to 66 years. Find the present ages. It basically says that after 5 years, if you add both of their ages, it will be 66 years. Meaning what? At present, the age of uh, the age of Sahil and his mother are what? It is X and 3x. So after 5 years, it is going to be what?
Yes, sir.
We will add 5 to Sahil's present age. That will be X plus 5. And we will add
Yes,
add
sir.
5 to his mother's age. That will be 3x plus 5. And if you add these two values, x plus 5 and 3x plus 5, that is what the question is saying will be equal to 66 here. Okay.
Yes, sir.
So if you add their ages after 5 years, it will be equal to 66 years, which is 4x plus 10 should be equal to 66. Got this, Ahmed? What is the confusion in
Yes,
the
sir.
given question? Okay. Okay. So that's how you need to solve. So in this, you will find the value of x here. Okay. So if you were to try to solve this, 4x equals to 66 minus 10. Okay. So that will be what, 56, and x is going to be what here? It is going to be 14, right? So the present age x which we found here is the present age whom? His mother or Sahil?
Uh,
Look, we assume x as the present age of Sahil. So it has to be present age of Sahil, this 14. Okay.
yes, sir.
And
Yes.
what would be the present age of his mother? It will be 3x, meaning 3 multiplied 14. Okay. That will be 42.
Okay.
Right. Okay. So that is the question. Now, after 5 years, if you see the present age of Sahil, which we found out to be is what? Present age of Sahil is 14 years. Present age of his mother is
Yes,
what?
sir.
42 years. Now, after 5 years,
Yes.
their ages are going to be 14 plus 5, that will be 19 years. His mother's age will be 42 plus 5, that will be 47 years. Now, read what did the question said in the next line.
Um.
Their ages will add to 66 years after 5
Okay,
years.
sir.
So after 5 years, if you add their ages, it should be equal to 66. So we can check that also. So 19 plus 47, isn't it equal to 66? 47 here, it is 47. Okay, what do you
Yes.
get if you add 19 and 47? You get 66. So that is the question. Okay, I hope you got how we solve this question. Yes, Ahmed?
Yes,
If
sir.
there's any confusion, I will explain again. Don't hesitate.
No question, sir.
Okay, very good. So submit the solution of exercise number 1